Hello, in this video we're going to introduce inverse trigonometric functions, specifically arcsine, arccosine, and arctan. These functions allow us to work backwards from a trig value to find an angle, which is something we'll use constantly moving forward. Let's get started. By the end of this lesson, you should be able to understand why we need to restrict the domain of a trig function before defining inverses. You should be able to define and evaluate arcsine, arccosine, and arctangent. You should be able to apply properties correctly and recognize when they do not apply. And you should be able to evaluate compositions using right triangle reasoning. This lesson is really about building a strong foundation, especially for later topics like applications and calculus. Let's start with the fundamental question. Why can't we just take the inverse of sine, cosine, or tangent as they are? The issue is the horizontal line test. For a function to have an inverse, it must be 1-to-1, meaning each output corresponds to exactly one input. But sine fails this. For example, sine of pi over 6 and sine of 5 pi over 6 both equal 1/2. So if I ask, what is the arcsine of 1/2, which angle should I return? There are infinitely many possibilities. So what do? We restrict the domain to a region where the function is 1-to-1. For sine, we use the interval from negative pi over 2 to positive pi over 2. On that interval, sine is increasing and takes every value between -1 and 1 exactly once. We'll do something similar for cosine and tangent, choosing intervals where each function behaves nicely and is 1-to-1. Now let's define arcsine. When we write y equals arcsine of x, we mean y is the angle whose sine is x. There are a few key things to remember. The domain is from -1 to 1 because sine values cannot go outside this range. The range is from negative pi over 2 to pi over 2. This is the restricted interval we chose earlier. This function is increasing and passes through the origin. Also very important, arcsine of x does not mean 1 over the sine of x. It is an inverse function, not a reciprocal. When evaluating arcsine, always ask, what angle within the interval negative pi over 2 to pi over 2 has this sine value? For example, arcsine of 1/2 is pi over 6, because that's the angle in the correct interval whose sine is 1/2. Arcsine of negative square root of 2 over 2 is pi over 4. It's negative pi over 4. And arcsine of 0 is 0. But arcsine of 2 is undefined because sine values cannot be greater than 1. Always check the domain first. Now let's look at arccosine. Y equals arccosine of x means y is the angle whose cosine is x. The domain is still -1 to 1, but the range is different, from 0 to pi. That means all outputs are non-negative angles. Unlike arcsine, arccosine is decreasing. One useful identity to remember is that arccosine of x plus arcsine of x is equal to pi over 2. This works because of how the ranges are defined. Now for arctan. Y equals arctan of x means y is the angle whose tangent is x. The domain here is all real numbers. Tangent can take any real value. The range is between negative pi over 2 and pi over 2, but it's an open interval. It never actually reaches these endpoints. Instead, the graph approaches them as horizontal asymptotes. This is different from arcsine and arccosine, which are bounded and reach their endpoints. Here's a quick summary of the 3 inverse trig functions. Take a moment to notice the patterns. Arcsine and arccosine both have domain of -1 to 1, but different ranges. Arctan has a completely different domain, all real numbers. These differences are very important when evaluating expressions. Same idea as before, we are always looking for an angle in the restricted range. For example, arc cosine of square root of 2 over 2 is pi over 4. Arc cosine of negative 1/2 is 2 pi over 3. And arc tangent of 1 is pi over 4. For arctan of negative square root of 3, we get negative pi over 3 because that's the angle in the correct interval. Always check the range before answering. Let's test our understanding. What is the arc sine of 1.5? Why is the arc sine of 1.5 undefined? Well, because it's outside the domain. What is arc cosine of negative 1? Well, that's pi. Now here's an important one. Arc sine of 2 pi is not 2 pi because 2 pi is outside the allowed range. So we evaluate sine of 2 pi first, which is 0, and then arc sine of 0, which gives us 0. This is where students make often mistakes, so be careful. Here are the key inverse properties. These only work when the inputs are in the correct domains. For example, sine of arc sine of x equals x always works for x between negative 1 and 1. But arc sine of y only works if y is in the restricted interval. If it's not, you must adjust the angle. That's why arc sine of 3 pi over 2 is equal to negative pi over 2, not 3 pi over 2. Always check the range before applying inverse properties. Let's apply these ideas. The sine of arc sine of 0.7 is just 0.7. The property applies directly. Arctan of arctan of negative 18 is negative 18. But arc sine of 9 pi over 4 requires some extra work. We rewrite 9 pi over 4 as pi over 4, then evaluate. Always simplify the inside first if needed. Now we move on to one of the most important techniques. To evaluate expressions like tan of arc cosine of 2 pi over 3, we use a right triangle. We let theta equal arc cosine of 2 over 3. So arc cosine of theta is 2 over 3. We build a triangle using that ratio, find the missing side using the Pythagorean theorem, and then evaluate the new trig function. This method is extremely powerful, and you will use it often. Same process here. Define theta, build the triangle, find missing sides, and evaluate. One important detail, pay attention to the sign. For example, if theta is in a range where sign is negative, that tells you which quadrant you're in and which signs to use. Sometimes we want a general expression instead of a number. We follow the same triangle idea, but now everything is in terms of x. For example, sine of arc cosine 3x becomes square root of 1 minus 9x squared. Also, always state the domain because the expression only works when the input is valid. Now let's try some more practice. These reinforce when inverse properties apply and when they don't. This is where careful thinking matters, not memorization. Try these out for yourself and then check your answers. Inverse functions are reflections across the line y equals x. So points swap coordinates. That's why the domain and range switch between a function and its inverse. This helps visualize what's happening graphically. Here's your full summary. At this point, you should be comfortable with domains and ranges, behavior of each function, and how inverse properties work. And these graphs reinforce everything we've discussed. Notice the shape, the asymptotes for arctan, and how arcsine and arccosine are bounded. These are the most common errors students make: confusing inverse with reciprocal, forgetting domain restrictions, mixing up ranges, and misapplying inverse properties. If you avoid these, you'll be in great shape. Now try this on your own. Focus on identifying the correct interval, building triangles when needed, and checking domains. Let's summarize. We learned that trig functions must be restricted before defining inverses. We defined arcsine, arccosine, and arctan. We saw how inverse properties work and when they fail. And we used right triangles to evaluate compositions. See you next time.